So let me start by talking about these two-dimensional arrays. Well, let me ask a question. What issues are people running into with PA4? What are the things you're popping into that are frustrating?
So, I have the entire program up and running.
Okay.
Recording all the phrases, putting them in order. But I'm encountering this really odd scenario where the longest phrase is the last phrase. So it prints that out, but it includes a really a weird abstract character.
Like a little gray square or something?
Yeah, exactly.
Chances are that's your EOF.
That's true.
And when you read EOF from getcar, make sure you're not storing that as a new phrase.
So you can't swap pointers inside of an array.
So we may get to this today. But those are fundamentally different things, right? This is really a two-dimensional array. It means the 201,000 characters that are stored in this come sequentially in memory one after another. And your variable just tells you where the first character is, and then it's just all laid out. 201 characters, 201 characters, 201 characters. This is totally different. This is really a one-dimensional array where each element is a pointer which points to another array. And these arrays that are being pointed to could be sequential, but probably aren't. Okay, if you've got this kind of structure, yeah, you can totally say, okay, let's take this thing and point here, and let's take this thing and point here. And you can swap by just changing pointers. With this, there's really no way to do that. You've really got to copy characters because there's no pointers, right? It's just where they are relative to the beginning of the two-dimensional array. So if you go totally away from the fixed 1000 by 201 and just do car star star, yeah, you can do that. But CPU time is cheap, right? So you can do it as a challenge. What other things are people running into?
Walls.
Walls. What kind of walls? What's written on the wall?
It's a glass wall.
Oh, interesting. So you can see everything. Yeah.
So sometimes it works fine, and then other times you get seg fault.
Ah, interesting. When you do something that gets a seg fault, if you do the exact same thing again, do you still get a seg fault?
Yeah, but then if I keep doing it, then it'll work.
Even with the same input?
Yeah, I just use 4 and be easy.
Ah,
Repeat it.
interesting. Okay, so this is where GDB can help,
Okay.
right? So if you compile with a G switch, G, and then run it with GDB, when it seg faults, it will usually tell you where it is in your program.
Okay.
And that can help you start trying to pin it down. But you could try making a better understood test case, maybe. Make a file with well, that may not work though. I was going to say make a file with 1001 phrases, or make a file with one really long phrase. But yeah, if you can figure out where that seg fault's happening, that'll tell you a lot. The other option is just start throwing in a bunch of print statements. So about to store a phrase, store the phrase, and then print out I just stored a phrase. Or I'm about to look for a new phrase, find a new phrase, I just found a new phrase. And that will tell you, what's the last thing it did before it seg faulted. That's another way to pin it down. And that'll at least tell you if you got a long phrase or you got too many phrases or something totally different.
Doesn't it just seg fault and then there's no code that's run?
When it seg faults, it exits, yeah.
What I'm asking is, I remember, I think in a really earlier building, like 2412 or something like that. I got a seg fault, but then I put a print statement before the issue, which I eventually found after GDB. But it actually wouldn't show the print statement, it would just seg fault.
Did you have a new line at the end of the print statement?
Oh, I remember.
Yeah, so this is an annoying thing about C. When you say print F, if you don't have a new line at the end, it doesn't actually print it right then. It usually only prints when you get to a new line. So if I print 5 things, I may not see those until I print the 5th one, which has a \n at the end. Or you do something that asks for user input or something like that, because it buffers the output. So, and that's annoying when you get a seg fault, because it probably already printed the thing, but you just didn't see it, and then the program gave up. Yeah.
So I want to practice more on
Yeah.
just like data structures and malloking.
Mm-hmm.
If I want to dynamically allocate spaces as I'm storing them instead of using arrays,
Mm-hmm.
is there a special way to free up that malloc string array?
Yeah, so if you, so let's say you have a temporary character pointer that you're going to store a phrase in, and your phrase is, 50 characters long. Okay, so you could do something like temp equals malloc, whatever, the phrase length is, right? And then you go ahead and you do some stuff with temp. If you want to free this memory, just use the same variable temp. Basically, you want the address of the first block that was allocated.
Yeah, that's the thing. I tried that for some reason I'm losing.
Are you running it through Valgrind?
I have, yeah.
Okay.
Yeah, so like anytime I store a string into that malloc space, it's not able to release the memory.
Are you getting warnings from Valgrind while the program's running? You know how sometimes it gives you all this back
Yeah.
talk? Are you getting those?
Yeah.
Okay, so yeah, something's not lined up, either where you're allocating or where you're trying to free.
Okay.
Are you using 2-dimensional arrays in here?
No, so I'm just creating
So
a
just one?
structure.
Okay. Yeah, show it to me after class if you want.
Okay.
We
I'll
can
just redo
we
it.
can dig into that.
Okay.
Cool.
But the general rule is just free.
General rule is whatever malloc return, it returns an address to you, right? That's the argument you want to pass to free.
And you have to do that to the contents and the node itself if you will use a structure.
So malloc just gives you an integer, right? Which is like a 64-bit address,
Okay.
right? That's the thing that you pass to free.
Oh.
Has nothing to do with what eventually got stored in temp, right? It's really just the address that malloc returns. So malloc returns the first of, in this case, len bytes of memory, right? So you have to pass that address of that first byte to free. And if you try to pass something like the second byte address, right, then you'll get those warnings from Valgrind while you're running.
Okay.
And if you save this in temp and then somewhere along the way you set temp equal to something else, right, that's a memory leak. You've lost reference to this address. And if you try to free this thing, which is different from what malloc gave you, then you'll get another warning from Valgrind. So that might be going on also. Yeah, dynamic memory is strange, and for 224 you don't have to use it, right? But we will in 222. But yeah, show me after class if you can. Other things you're bumping into? So in the section A video, we spent a chunk of time working through code that uses this 2-dimensional array character 1000 by 201, and just kind of looked at ways that we can do, that we can treat this as an array of strings. So if we have a car 1000 by 201 dictionary, if we take dictionary bracket something, just remember that's a character array of 201 characters, right? Which means it's a string. We can use it in string copy, we can use it in string length, we can use it in printf with a %s, We can use it in string compare, right? It really is a string. It's just like a character bracket 201. So if we say something like character temp bracket 201, anything we can do with temp, we can do with dictionary bracket I. Okay, that's one way to think about it, including passing it to functions, using it in functions, things like that. So we worked out a bunch of details on that in the previous section, and we wrote some code corresponding to that. So look at that if you're having issues with this. It's right in the beginning of the 10 o'clock recording. So let's spec out this phrase reading business. Let's write some code. So we've talked about super duper get car, right? Read a character and pre-process it and make sure it's a character you care about. So going forward, I'm going to assume that when I call get car, I get a good character that I care about. It's uppercase. If it was a white space, it's a blank, and it's not a quote, double quote, hyphen, parentheses, close parentheses. So these things are taken care of. The next challenge is basically to read a phrase. Right? We want to use getCar to start pulling in characters, and we want at the end of this process to have a character array which contains the next phrase from our input. And then we're going to, store it in our dictionary and so on and so forth. So what we really want right now is something like next phrase. And I might write my function like this. I call it next phrase. It takes a character array of 201 characters. I could do car star, but you can make everything fixed length if you want. So it takes this, and this is the array into which I'm going to place the phrase that I read. And I'm going to return an integer. And my return value might be something like this. Return 0 if success, or EOF if I hit the end of the file. Because when you're trying to read a phrase, it's possible you're going to hit the end of the input, and you need to know that, otherwise you're just going to keep calling next phrase again and again and again. So I'm going to let next phrase return EOF, which I know is -1, right? And I'll just return a 0 otherwise. Or maybe I'll return a 1, or whatever you like. But I'm going to use this return value to know if I ran out of stuff. Otherwise, my expectation is when I call this function, if it returns a 0, out contains a phrase. And if I call it again, out will contain the next phrase from the input. And I can just keep calling this. And I can put this in my main program really easily. Right? I could just call this as long as it doesn't return EOF. And I could copy out into the next location in my dictionary. And now I've got a way to build a dictionary of phrases where I'm not paying attention to duplicates. So if the phrase comes in 5 times, I'll put it in my dictionary 5 different spots. But if I want to test my phrase reader and my dictionary set up right, that'll work fine. Or I could make a main program which just does something like this. While next phrase out is not equal to EOF. All right, there's my whole test program. So it calls next phrase. I have to declare out. So declare your output array and just call next phrase. If it doesn't return EOF, take the new value of out and print that out. And if I run this on, War and Peace or something like that, I should just get a nice list of phrases coming out one after the other with a bunch of spaces in between them and angle brackets at the beginning and end. So let's flowchart what we have to do to make this next phrase function. And if you want to write that, right, you could test it with a main program like that, for example. Or you could just call next phrase a few times and print out the result each time and so on. But let's look at this business of reading a phrase. So here's our next phrase. Well, the algorithm is really described here in pseudocode, right? Well, not an algorithm exactly, but a phrase begins with any non-space character other than one of these magic characters. It's a collection of consecutive stuff, not including these magic characters, and it ends when we encounter a magic character. So how do we read a phrase? Let's call get car. I'm going to put a little asterisk down here to remind you this is super duper get car. Okay, so read a character that's been pre-processed. Let's throw it into just an integer called C. So when we first call next phrase, right, the assumption is that we're looking for the beginning of a phrase. We're not going to call this when we're halfway through a phrase in the file. And the first time we call this, we haven't read the first character from the file yet, so we're looking for the beginning of a phrase. So the first thing we want to do is find something which is not a space and not one of these 6 special characters that marks the beginning or end of a phrase. So we read a character C, and we can say, is C equal to a space, a period, a comma, a semicolon, a colon, an exclamation mark, or a question mark? Is it one of these things that says we're not at the beginning of a phrase yet? And if it is, we should go back and get another character. So a phrase begins with something that's not one of these characters. So what we're doing up here is looking.
In your super duper get car, could you just return like
a flag?
Yeah.
Yep, totally. So you could pass a variable to it and it could set that variable to tell you if it's one of these things. That would be cool. Alright, so we're looping and we're looking for the start of a phrase. When we read a character and it's not equal to a space, period, comma, etc., right? Now we know that character is the first character of our phrase. And our goal now is to start ingesting characters, and as long as these characters are parts of our phrase, we want to build up this phrase, right? So we have to save these somewhere. So I might say something like out bracket 0 equals C. And same thing we've done before, we're going to need something that tells us where should we save the next character in our output array. So out is our output array that we're building up. And I'm going to say out location, outloc is where we're going to save the next character. So the first character we read that belongs to our phrase, we store that at location 0. I'm going to set outloc equal to 1.
Could you just do outloc plus plus?
As long as you initialize it to 0, yeah. Alright, so phrase is a collection of characters other than these characters that we're supposed to use to terminate our phrase. So now we're going to have another loop. So this is save first character of the phrase. So now call your get car. And again, is C equal to, well, we don't care about spaces at this point, we only care about the magic 6. And if it's not one of these, then we want to save it in our output. So let's set out bracket outlook plus plus equals C. So that saves it at location outlook and then increments our output index. And then we go back up and we get another character. So this loop here is saving input into the phrase, which is our variable we're calling out. So read a character, it's not the end of the phrase, save it in our output. Read a character, it's not the end of our phrase, save it in the output. Keep doing that loop. When we get to the thing that terminates our phrase, what's the one thing we got to do now? Think ODPs, think you don't want a segfault, you don't want something extra at the end.
Yeah, the null terminator.
Add a null terminator to the end of our output. And the way that I've been doing this, outloc is always the location where the next character should get written. So the null terminator is basically the next character in our output array, so this is actually just out bracket outloc equals null terminator. And if we're going to do this idea of return 0, if we succeeded in loading a phrase into out, now we can just say return 0. So that's most of the read phrase function. Right? Find the beginning of a phrase, save the first character, make a loop that saves everything else into the phrase. And then this is terminate the phrase. So throw that null terminator on. So far, does this make sense? What parts are a little iffy? Or is it the whole thing? So this can be broken down further, right? We could just write this piece of it and think about on paper, what is this doing? So picture your input and get a character. If it's a space or a period or something, get another character. Keep doing this. When you come out of this loop, C should be the first character of your phrase. So you can code that, and you can, use fgets to type in, or just use plain old getCar and start typing in stuff. And if you type spaces and new lines and periods and things we're ignoring, quotes and so on, it should just keep looping. And then when you type the letter Q, right, it should kick out of this loop, and it should say, I just saw on the start of a phrase, it's the letter Q, right? And that tells you that your code is working to identify where a phrase starts. And, you could forget about saving it for now. You could just do this part, forget about saving it there, just keep looping until you find one of these things. And now you can type in stuff that looks like, regular input. And when you type in a comma, it should come out and say, hey, I just found the end of the phrase. Right? And I just saw a comma, that's where the phrase ends. So you can just write some code to work on this piece of logic. And then maybe write some code to work on this piece of logic. And then put in some code so that while you're looping through here, you're saving the characters that you read into an array. And this is very much like some of the ODPs we've done, right? Where we built up arrays by putting things into them one character at a time. But instead of reading from an input array with an input loc, right, we're just reading with getChar, but we're still saving in an output array, and we're using this output location and incrementing it. And this right here is, 95% of what you need for the phrase reader in PA4. And you can certainly take this and you can feed it War and Peace, and each time you call next phrase, it should come back with the next phrase from War and Peace, right? Or maybe a shorter file to start with. And it's not saving them, it's not counting them, but we're not trying to do that. We're just trying to parse the input, basically. And this is probably the trickiest part of PA4, is figuring out what's a phrase and being able to read that. If you can do that, the rest of it is pretty close to things we've already done. So this isn't a bad piece to work on early. Okay, so what's missing in here? There's at least 2 glaring omissions in our flow chart. Well, maybe not glaring, but if I call next phrase in a loop, the way you've written it, is this loop ever going to exit? Is next phrase ever going to return EOF? Right, it loops here, eventually it returns a 0. So we need something in here that can detect when we've hit the end of the file. And suppose we call getChar and C is equal to EOF. Well, it's going to fail this test. It's not going to be a space period comma, so it'll come through here. We're going to store EOF in our output phrase. And then we're going to come down here, we're going to call getChar again, which is probably a problem. So really we want to do something probably here. If C equals EOF, return EOF. And we might find the start of a phrase, and while we're reading it, before we get to the end of the phrase, we're sitting in here, we might also hit EOF. Because not every file ends with a period or an exclamation mark, right? So we probably want a similar test here. If C equals EOF, return EOF.
Could you put the whole thing in a while loop and be like, if it's not equal to EOF?
Mm-hmm. Yeah, we could put the whole thing in a while loop, except we kind of need to do getChar in 2 different places. Right, one in the beginning when we're looking for the start of a phrase, and another later when we're looking for the end of a phrase. So you could do a pair of while loops maybe. But if we wanted to code up, just say the first piece of this, right, this will probably look similar to things we've already done. How do we code a while loop like this? Typically we do something like this. C equals super duper getChar, while C equals space or a dot or, right, and that's not valid C syntax. But while C is equal to one of these things we want to ignore, C equals getChar, and a closing curly bracket. So that basically codes up this part of the loop. And this, again, is the same thing as, enter a number 1, 2, or 3. While the answer is not 1, 2, or 3, enter the number again. Same structure we did in stick picking. So get a character, well, it's something that we should be ignoring, get another character. Until we come out of this while loop, and then we know C is the first character. So throw in your EOF check here, and so on. And then same thing down here, get a character, and while it's not equal to one of these things, right, save it in the output location, get another character. All right, the other thing that's missing here is that there's nothing to stop our output phrase from getting arbitrarily long. right? We know that we can only store 200 characters plus a null terminator, and there's nothing here to stop this from overrunning. So we need some kind of check in here. And our output location gets incremented here. So this is probably a good place to throw in a check, and there's a number of ways you can do this. But for example, you could say if outloc, so this is where index arithmetic can be confusing. So out right, so this is what our output array looks like. It goes from index 0 through 200. That's 201 elements. So the last place we can store a character is at 199, and then a null terminator at location 200. So we can store if outloc is less than or equal to 199, then we're okay storing our character in our output array. And if outloc is as big as possible, if it is 199, we're going to store that character here in the 200th spot of the array. And after that, outloc's going to be 200. So if we find more characters after that, this test will fail. We won't store any more characters. And when we finally find the null terminator, we'll store it at location outloc, which is 200, which puts the null terminator right where it should be. So the effect of that one if statement around this assignment is the first 200 characters get stored into out, and then if you find more characters, we just kind of silently ignore them. And then when we hit the end of the phrase, we pop a null terminator on the end. So your phrase will look like the first 200 characters of the phrase. And there's different ways to manage that, but that's the idea. And there's your phrase ingester, basically. So what I'm hoping this helps you with is this idea of breaking things down into pieces, right? This is certainly a piece that you can develop regardless of anything else in PA4. You don't need a dictionary, you don't need to sort, you don't need to super duper get car, right? You can use plain old get car and write this piece of it and just feed in text from a file, and it should break it up into phrases for you. And you can break this down even further. So this and this are pretty similar. This is looking to see if C is equal to a space or one of these 6 characters. This is just looking for one of these 6 characters. Well, you could make a function called isStartEnd, takes a character and it returns a 1 or a 0. And if the character you pass it is a period, comma, colon, semicolon, exclamation mark, question mark, this returns 1. Otherwise, it returns a 0. So what does this first diamond if statement look like? If C equals a space or is start end C. All right, there's your if statement. And that's easier when you're reading through your code late at night to know what you meant to do here, as opposed to a bunch of ampersands and pipes and parentheses and things like that. If C is a space or if it's a start or end of a phrase. And this second diamond down here is just if is start end C. Or if you want to know if it's not the start or end of a phrase, you could say if exclamation mark, if not is start end, if you want to branch off of the other condition, right? And this can be a function, and that's a pretty simple function to write. It takes C and it basically just does your big long if statement. If C equals a period or C equals a comma, etc., return 1, otherwise return 0. Or you could do 6 if statements, or you could do a switch statement, with a case. Lots of ways to do that. And this is start end function is a pretty easy one to test by hand, right? Call is start end with a letter A and see what it returns. Call it with a period, see what it returns. Call it with an exclamation mark, see what it returns, right? So one of the challenges in programming is sort of the dreaded empty screen, right? You got the blinking cursor staring at you, accusing you, why haven't you written anything yet, you know? And it's a totally blank page, and that's a really hard thing to get past. That's writer's block, right? That's the famous empty page in the typewriter. If you can break your problem into smaller and smaller pieces and get to a piece that you can write, it gets you past this, and that's a huge mental hurdle, right? And once you have code, it's usually easier to start adding things to it. Even if you have to undo some of the stuff you've written, it's usually easier to start adding stuff than to start from like nothing and try to start making code. So anything that you can do to make progress, I'm just going to make this function called is this the start or the end of a phrase, right? Is definitely going to help you. Because that's intimidating, you know. And once you have 5 lines of code written, right, it's a whole lot more comfortable. It's like, okay, I'm on my way, I'm making progress, I just have to keep going now. And, you know, one function at a time, one line of code at a time, and you'll get there eventually. All right, questions about this? So what do we do with this once we're reading phrases? Our main program is basically like this. All right, that's the bulk of what the program's going to do. Well, I'll read phrase out, save phrase out. Read a phrase, save it in your dictionary, read a phrase, save it in your dictionary, and I'll set up read phrase so it returns a 0 on end of file, and that'll kick me out of my while loop. And then it's like print or sort dictionary and print dictionary. Pseudocode, not C. Okay, so let's take 5 minutes. Let's look at this save phrase business. And save phrase is actually going to be more complex. So save phrase, well, we need to have the phrase that we're going to store. That's a character array. We need to pass it the dictionary itself, which is a 2-dimensional array. We need to pass it the array of counts, right, the number of times each phrase occurs, and we need to pass it the number of things in our dictionary, which I'll call dictionary length. So this says here's an array of phrases, here's an array of the number of times each phrase occurs, here's the length of those arrays, and here's a new phrase. And I want to store this in the dictionary if it's new, or I want to just bump up the count in the dictionary if it's already in there. So let's hold on to that prototype, and let's write some code in a flow chart. All right, so this is our save phrase. We're down to 4 minutes. Is the phrase in the dictionary? Assuming it is, and assuming it was found at entry I in the dictionary, what do we want to update? What do we want to adjust? a count, right? So what element in count? Count bracket I. And that's really all we have to do. If the phrase is already in the dictionary and it's the ith entry in the dictionary, just increment count bracket I. If we had found this phrase 6 times, now it's going to be stored that we found it 7 times. If it's not in the dictionary, got to do a few more things. We want to add it to the dictionary. Okay, again, if I have this dictionary length representing the number of things in the dictionary, this is the index where I should store the next thing. So I want to save the phrase in dictionary bracket dictionary length. These are strings, so I can't just use equals to assign them. I have to use something like string copy. So string copy takes a destination, such as dictionary bracket dictionary length, and then it takes the thing that you want to copy, which for us is phrase. So that copies phrase into element dictionary length. And then we have to set the count of how many times we've seen this phrase. Well, this is the first time we've seen it, so we'll set count equal to 1. And then we have to increase the dictionary length to say, hey, we've got another thing in our dictionary, and then we can return. So that's really the essence of your save phrase. And there's 2 details you have to add to this. The first is, how do we tell if your phrase is in the dictionary? Well, if someone hands you an array with 20 phrases in it, and you've got a new phrase, and you want to know if this matches any of those 20 phrases, write a for loop. Right? Just loop from I equals 0, I less than dictionary length, I plus plus. Use string compare on dictionary bracket I with phrase. If string compare returns 0, then the phrases match. And the current value of I, that's the count that you want to bump up. If you go through that whole for loop and you haven't exited, the phrase is not in the dictionary, so you go ahead and you add a new one to the end. And the last thing is, you need to make sure that you don't let dictionary length get too big. So this is all if dictionary len is less than 999. Actually less than or equal to 999. If it's less than 1,000, you still have space in your array, so you're okay to do all of this. But as soon as your dictionary is full, dictionary len will be 1,000. You don't want to copy the phrase into there. You don't want to set a count to 1. You don't want to increase dictionary length. So throw all of this inside a big if block, and there's your phrase save. And you can do this without anything else in PA4 working. You can just make a dictionary as an array, and you can just type in phrases through standard in, use fgets, and just pass them to save phrase, and you can test this part and build it up. Right? So all these pieces can work independent of each other, but when you've got them all working and they're all going great, right, you can throw them all together into a 5-line main program, and suddenly PA4 is done. Yeah. All right, so think about those. Pop notes on Discord or email if you're getting stuck on some of this stuff, but start writing some code if you haven't already. Remember, no class on Monday. It's a Clark holiday, and I will see you next time. And that's still doing its thing, doing more stuff.
You laugh.